Welcome to Reality Creative Video. I'm Hermes. Today is Alchemy again. We're going to talk about van der Waals forces, vanadium, colloidal carbon, colloidal chromium, colloidal cobalt, and a bit about my forever mix. So stay tuned. Here we go. What I'm trying to do here is I'm trying to create what I call my blood sugar buster, and that is composed of vanadium, chromium, and cobalt. And this stuff here is the mixture of the three. Even though it's perfectly clear, and these things have all different colors, actually the mixture winds up being clear. And, preliminary tests, which is just really me drinking it, it's very promising, extremely promising. Now, the problem I have with it is my vanadium is unstable. I got my chromium stable and my cobalt stable. My vanadium will only last about a week, if that. So this is last week's vanadium, and this is this week's vanadium, which I cooked up a couple days ago. Notice the coloring is virtually the same. What's the difference between them? This vanadium no longer has any colloidals in it. It is completely a ionic substance now. This one still has 12 to 15 parts per million colloidals in it, and plus the ionic content. Now the goal here is to create a stable colloidal content. So I had to make more of this stuff up so that I could make more of this stuff up to continue testing it. And this stuff is going to go down the toilet because, well, not much use for, at least for me anyway, for an ionic vanadium solution. Doesn't mean it's not useful. We talked about ionic substances and colloidal substances and how, they can be, ionic substances can be useful, though colloidal substances are far more potent, and readily the body can use colloidal substances a lot easier than it can break down ionic substances. So that's my goal. Now, there are two ways to make colloidals. We've talked about that. There is plasma arc, and there's low voltage electrolysis. Now, this is low voltage electrolysis method. I may have to order some vanadium sheets or wire so I can try the plasma arc of creating vanadium to see if I can get that long-term stable using plasma arc. And plasma arc process and the low voltage electrolysis process of creating colloidals is a little different. The low voltage electrolysis way of creating a colloidal is through chemistry. And the plasma arc way of creating a colloidal is through physics. Both do it differently, but then result winds up the same. You have a metal or something suspended in the water, and they clump together to form little communities, nanoparticles, anywhere between 100 and 1 nanometers. And they're quite large particles compared to ionics, which are in the picometer range. But they're suspended, so they're trapped in the water unless the body wants to use it, which makes it very, very good because you don't have to worry about overdosage. And the body has a mechanism built into it that knows what to do with a colloidal. Not that it doesn't know what to do with an ionic, but ionic substances flood the entire body with the substance, and the entire body may not need the substance. And so you'll get like little small concentrations of the substance all over the body, and maybe not enough where you need it. But when you put a suspended particle in there, a colloidal, it's in the water in your system, and it travels throughout your entire body. And so if there's some part of your body that needs that particular colloidal, it says, oh, okay, I can use this, and I will. And if nothing happens and the stuff isn't used, you pass it out, in your urine stream. It's a really cool system. I want to talk about these two vanadiums, and I want to show you the difference between them. Now, it's important when you make your colloidals, not all your colloidals are going to last forever. Some of them are going to break down. It depends on the colloidal. Colloidal silver pretty much you can't do anything wrong with colloidal silver. It lasts forever and ever and ever. But the other colloidals, like colloidal gold, eventually it's going to break down and it's not going to be a colloidal anymore. I mean, you might get 6 months or 8 months out of colloidal gold. It really depends on what you're cooking. Zinc has a life expectancy. I found it's not a forever colloidal, but it lasts long enough. And then vanadium, I would like to get to last long enough, but weak is not long enough. With that said, there are these two kinds of vanadium. This has got colloidals, that doesn't have colloidals. And it's important that you test your colloidals. I have the video laser microscope, which makes it very, very handy for testing colloidals. I put it in a little dish, and I stick it in the microscope to see if I got colloidals there. But a lot of you guys don't have that, so we use our trusty green laser to do it. So in this beaker, I'm going to put vanadium, ionic vanadium, which was vanadium colloidal a week ago. And in this beaker, I am going to put my brand new stuff that I cooked the other day. That still has the colloidal in it. I checked it in the video microscope to make sure. You never know how long this stuff's going to last when you're still in the experimental stage. So, okay, so here we go. This is the way it's supposed to look. All right? All right, wait a minute. Don't forget the shades. Okay? All right, this is the way it's supposed to look. All right, you see the colloidals suspended in the water here? That's the way it's supposed to look. This is what happened after a week. As you can see, there is very little colloidals in here at all. And, the color, not that you can tell here, I'll shoot a picture of it. The color is pretty much the same. This has a colloidal in it. This is all ionic. So you have to be careful with your colloidals, and we have to find a way to keep the colloidals together. And there's a mysterious force called van der Waals forces that it's responsible for keeping the colloidals together. And it's not fully understood completely on how they stay together. I mean, van der Waals forces are pretty much understood. They're non-charged particles, which is what our colloidal is, that momentarily have a charge on one side of them because all the electrons, for a moment, decide to pop up on one side of the atom. This causes a very slight imbalance between the one side of the molecule is going to be a little negatively charged and the other side is going to be positively charged, which then affects the one next to it. And that will cause that molecule to also charge, line up, like a battery, positive, negative, positive, negative. Then they start clumping together and into nanoparticle sizes, and that's how we get our colloidals. But something happens, the van der Waals forces are extremely weak force. In water, we have a lot stronger forces. The bipolar nature of water is much stronger than the bipolar nature of the van der Waals forces. And so there's a constant battle going on where the water is trying to erode away the colloidal. And that's where a capping agent comes in. And the better the capping agent, and I call a capping agent a force field. And that's not really truly, science doesn't really truly understand capping agents. They know they exist. I mean, in some of the scientific papers that I dug through, it's postulated that whatever you make the capping agent out of can actually affect the colloidal. So if you make the capping agent out of a toxic substance, and even if you remove the toxic substance from the colloidal, which is, believe it or not, that's what they do in the laboratory a lot of times, you still have a colloidal that was made with a toxic substance, and that force field that keeps the charge neutral is now made of a toxic substance and affects the colloidal. So there's a whole push to make sure we use green capping agents when we create our colloidals, which is why everything that I use is all household safe colloidals where you can just pretty much stick it in your mouth and drink it. Because if this capping agent that winds up trying to protect the colloidals from coming apart needs to be safe for us to drink. At least I want it safe for me to drink. And my friends and relatives and people I sell my colloidals to. So that capping agent becomes important. Now, in the case of vanadium, vanadium is really unstable. It has a plus 2, 3, 4, and 5 state. This light blue one is the plus 4 state, which is really the only stable state of vanadium. All the other states are unstable, and even if I cook a plus 5 or a plus 2, one's violet and one's yellow, eventually in a few days it all relegates back to plus 3 blue vanadium. What does that mean? That means that the colloidal that we create is already unstable because it has all of these oxidation states. So it doesn't take a lot for the forces in the water to pull apart the vanadium. That's why I'm having so much trouble keeping the vanadium together. What I have to find is a capping agent that is going to work well with the vanadium. In this particular beaker, I did something crazy and wild, and I don't think it's going to work, to be honest with you. But let me just tell you the things that I'm trying. I took zinc. I crunched it up, zinc powder, and put it in here before I cooked the colloidal. And then I cooked my colloidal, and most of the zinc that went in there did not dissolve. I had it floating all around. Now, zinc doesn't dissolve in water, but zinc will dissolve partially when you mix it with an acid. Now, so the vanadium I made with malic acid, or you can use citric acid too if you don't mind the mold. It doesn't matter. I use malic acid in here, and malic acid will also break the zinc down a little bit. And my thought was to create what they call what is my chemist calls it? I keep forgetting the name. A complex compound or something like that, where several things are happening. And so we got the acid, which is creating the colloidal, right? The malic acid is dissolving the vanadium into the water. And we got the acid, which is also breaking down the zinc and putting that into the water. And my hope is to make a zinc force field around the vanadium. Will it work? I don't know. It's just a theory. It's just something I'm trying. I won't know for a few days. Every day I test this to see if it's disintegrated any further. So far it's stable. I'll have to see. And that's the sort of thing I'm looking for now. I'm looking for really weird science stuff on creating a solid vanadium with low voltage DC. Trying to find a force field that will hold together and be able to withstand the polar forces that want to pull the vanadium apart, which is already weak to begin with. This is my forever serum, and what drives me forward with all of these things is to create a fountain of youth, a holy grail, if you want to call it, a substance that when you drink this, it puts everything in your body that you possibly need, and your body sits there and says, wow, I can now do the things that I needed to do. I have the copper, I got the iron, I got this and that I need, the vanadium, the chromium, the cobalt. I got everything I need to make the body work, instead of the body being wholly dilapidated because it doesn't have the chemistry it needs to create the robustness in the body. That's my goal, and I'm working towards that. My Vanadium-Chromium-Cobalt is my latest thing towards that, but I must get my vanadium stable. The next thing coming up, and you saw a short on that, is carbon. This is colloidal carbon. I haven't tested it yet. I'm still in the process of testing this stuff out. I don't like to test two things out on myself at the same time, but I'm doing research on colloidal carbon, and this might be another key to unlocking my holy grail forever mix of giving the body something it needs. Carbon is the basic building block of the body. And carbon is very friendly to the body. That's not toxic or anything like that. But nobody's thought about actually giving the body, I'm not talking about an ionic substance of carbon, but I'm talking about pure colloidal substance of carbon. Something that the body knows how to handle. And it can say, oh, wow, this is a carbon molecule. Holy crap, I can use this. I don't know. This is my speculation that we're missing a pretty big, important part of our diet. Carbon is usually made by when we eat our foods and we break down our foods. So carbon comes from that. But what if we could supply the body with a source of carbon that didn't have to break down? You know, our foods aren't the best these days. So maybe we're not getting the carbon that we need in our system. It's just experimental right now, but that is the thing that I'm going to be working on next. It's colloidal carbon. Once I get this vanadium thing squared away and I got my blood sugar trifecta here kind of sorted. That's about it. I know we kind of went with a long video today. But again, if you made it to the end of the video, you earned yourself another cool. I'm Hermes. Reality Creative Video. Alchemy. I'll talk to you again soon.